Hello students, today we are back with our next chapter, that is chapter number 5, continuity and differentiability. So before starting this chapter, first of all we have to understand about the terminology of this name of the chapter. Chapter's name is continuity and differentiability. We will talk later about the differentiability. Right now we are starting with the continuity. So first question arises in our mind, that is, what is continuity? What is continuity? So we can say a function is continuous when we can draw its graph without any break. Means whenever we are able to draw a graph without lifting the pen. So it is not an actual definition, but for understanding we can say this. Okay, suppose if we are drawing any curve like this, we did it without lifting any pen. If we have to draw a curve like this, we did it without lifting pen. But if we have to draw these lines, this is not continuous. Why? Because we have to lift the pen at once. Okay, so this is a continuous graph, this is a continuous, this is a discontinuous graph. Clear? So how can we identify that the function is continuous or not? So in this topic we are going to understand about the continuity of this topic. I hope it is clear. Now so we can identify the function by this equation, that LHL is equals to function at A is equals to RHL, where LHL represent the left hand limit, FA represent function at some point A, function at some point A, and RHL means right hand limit. If these all the three terms are equal with each other, then we can say a function is continuous. Now I will tell you what's the sense for this equation. Suppose this is a function. Suppose this is a function. We have to check at this point whether the graph is continuous or not. Okay, we can check on this point. Suppose that is x equals to a. Now what is left hand? When we said the graph is continuous, we can set means if graph is coming from some point, passes through a point and goes again through any other point. Okay, if graph is coming from some point, passes through a point and again move towards next point. Okay, so at this point this part is left part, so we can check it by left hand limit. This part is at the same point, so this is f of a, means function at some point A, and this is at the right side, so we can say this is the right hand limit. If all the three terms give the same result, if all the three functions give the same result, then we can consider that function as a continuous function. This question, this topic you can understand by a question. Suppose a function is given f of x, that is 2x plus 3 when x is less than equals to 2, and 2x minus 3 when x is greater than 2. You have to find the point of discontinuous. You have to find the point of discontinuity. Okay, for this function, first of all we have to check its left hand limit, whether the function is valid for the left side. Here this function is valid for, we have the value for at x equals to 2, so we can check for x equals to 2. So for LHL we have to move towards the left side of 2. When we subtract a minor quantity from 2, then we can get the left part. So we can mention is x tends to 2 negative, means something, a very small quantity we can subtract from this function, this number 2. 2 negative, then we get the less than, a value less than 2. For less than 2, this equation is valid, so we can use 2x plus 3. Now convert the limit in 0, so we can consider this h tends to 0, put 2, x will be replaced by 2 minus h. Why? Because we are subtracting something from 2, and that something is named as h. 2 minus h plus 3. If we simplify this term and substitute h equals to 0, we get 2 to the 4 plus 3, that is 7. Clear? We are getting LHL at 7. Now moving towards f at 2. Means when we substitute the value of x as 2, means for x equals to this function is valid. So 2 into 2 plus 3. 2 to the 4, 4 plus 3, 7. We get LHL 7, f of a 7. If we also get the RHL also 7, then we can set this function is continuous at all points. Means there is no point for discontinuity. Okay, now moving towards RHL. RHL means when we have to move towards the right side, then it means we have to add something in 2. Means we can write it as limit x tends to 2 positive. Means we have to add something in 2, and when we add something in 2, we get the value something that is greater than 2. Means x will be greater than 2, and for greater than 2, this equation will be valid. So now when we substitute h tends to 0, 2 plus h minus 3, and when we substitute the value of h as 0, so we will get 2 to the 4 minus 3, then it will be 1. So final result, we have the value for LHL, that is equals to f of a, but it is not equals to RHL. So we can say the function is discontinuous at x equals to 2. Here the graph will be broken, means the continuity will be dissatisfied. I hope it is clear to all of you. Now please pause the video to note it down. Okay, now moving towards our next topic, that is differentiability. Differentiability, or we can say differentiation. Okay, so what is differentiability? Differentiability, it is already clear by its name. It is a difference. Difference means, suppose when we plot a continuous graph, suppose this is the graph. Okay, here we are having some value of x. If we increase some value of x, suppose here, then because of just increment of the value of x, there will be a change in the value of y as well. Here the value of y is something y1, and because of this change we get some change in y as well. Okay, so basically the calculation for these types of problem means where we have to put some slight change on one variable, and there will be already some change occur in any other variable. So this ratio is basically known as differentiation or differentiability. Means we had changes in x from x1 to x2. What was the change? We will consider it by x2 minus x1. And what change we found? That is y2 minus y1. The ratio of these two terms is known as differentiation. This y2 minus y1 is known as dy, means change in y, divided by x2 minus x1 is change in x, and this is known as differentiation. Okay, if we have to find this in a function term, or we can say in a limit form, then we can write it y as a x1 and it is x2. It is Okay, we can do it later. So dy upon dx is limit x tends to 0 f of x2 minus f of x1 means change in y divided by change in x. If we have to write it in a simple way, in a simply x and y term, then we can write this as a x and this is x plus h. Why x plus h? Because here we have to add something in x. So we get the value x plus h. Now apply here f x plus h minus fx upon x plus h minus x. So x will be cancel out this, so, and here x will be convert to h tends to 0. So finally we can say dy upon dx is nothing but f of x plus h minus f of x divided by h, and this is basically known as first principle of differentiation. This we already studied in class 11th in limit and derivatives. Now we just have to get the formulas for differentiation which we already proved in class 11th chapter 13 limits and derivatives. We just use those formulas and solve the some derivative problem, or we can find the answer. I hope it is clear to all of you. Now we are moving towards some basic formulas of differentiation. Now please pause the video to note it down. Okay, now moving towards some basic formulas for differentiation. So we can write the heading basic formulae of differentiation. So write down some formulas. The differentiation d upon dx for any constant is always equals to 0, because when we find any difference in constant, suppose if we draw a graph, a constant graph, here y1 and y2 both are same. When we find the difference in y2 minus y1, we get the value 0. So we can say the derivative for constant is 0. Now d upon dx for x ki power n, that is nx n minus 1. This we already proved in class 11th chapter 13 limit and derivatives. Now next e to the power x, that is e to the power x d upon dx of log x equals to 1 upon x log ex, d upon dx of log ax is equals to 1 upon x log a. Now moving towards next formula, that is d upon dx of a to the power x, that is a to the power x ea. Okay. Now d upon dx of sin x cos x, that is minus sin x, d upon dx of tan x, that is sec square x, d upon dx of sec x, that is sec x into. These all formula you can derive with the help of first principle. Okay, so next one is cot x, that is minus cosec square x, d upon dx of cosec x, that is minus cosec x into cot x, d upon dx. Okay, here all the trigonometric terms are there. Now moving towards inverse trigonometric term. Cos inverse x minus 1 upon d upon dx of tan inverse x 1 upon 1 plus x square d upon dx of d upon dx of sec inverse x, that is 1 upon x square minus 1. Now these are some basic formulas for differentiation which we are going to use to solve some questions based on differentiation. Now I hope it is clear to all of you. Please pause the video to note all the formulas and try to learn it as soon as possible. It is very important for your syllabus point of view, for your JEE point of view as well. Please pause the video to note it down. Now moving towards the product rule of differentiation. Right till now we had done all the formulas based on the single number function. Now if we get any product function, suppose u and v are two function in the product form, we have to differentiate this. So we can write d upon dx of u into v. First u will be differentiated and v will be considered as a constant. Then next v will be differentiated and u will be considered as a constant. So it will be like this: u d upon dx of v plus v d upon dx of u. Suppose product is given for three terms, means u, v, w. Then in that case we have to differentiate all the terms one by one. The time when u is differentiated, then v and w will be considered as a constant term. Then differentiate u. Plus when v is differentiated, then remaining two terms will be considered as constant term. And at last when w is to be differentiated, then u and v will be considered as constant function. So this is the basic rule of product for differentiation. Now in the same way we have one more rule, that is quotient rule, or we can say division rule of differentiation. Suppose two functions are available in a division form, we have to differentiate it. So it will be denominator differentiation of numerator, that is u, minus numerator differentiation of denominator divided by denominator square. The only thing which we have to learn throughout the differentiation, the one thing we always need to remember, that each and every variable have to be differentiated. In differentiation, each and every variable have to be differentiated. Then only we can consider the final answer as a perfect answer of any derivative. I hope it is clear. Now please pause the video to note it down. Now moving towards our next topic, that is Rolle's theorem and Lagrange theorem. Both the theorems are basically the mean value theorem. Means the only difference between both the theorems are, suppose if we try to understand this with the help of a graph, if a particle is to be moved from the point and come back at the same point, then we can find their mid value with the help of Rolle's theorem. If we can throw an object from a point and if it will be stopped at any other point, then their mid value is to be calculated with the help of Lagrange theorem. The statement for both the theorems are almost same. We only need to follow some specific points for the equations to find the mean value theorem. So we can write it here. Statement for Rolle's theorem is f of x must be a real valued फंक्शन f of x हमेशा रियल वैल्यू का फंक्शन होना चाहिए. देन इट्स फर्स्ट स्टेटमेंट इज f of x is a continuous function. We can only calculate the mid value when function is continuous. Its second point, okay, we can also write their limit between a to b. Now fx is differentiable at between open interval a to b. fx हमेशा differentiable होना चाहिए. Then third point, f of a is always equals to f of b. Means suppose this is a point a, this is a point b, so here it shows fa and here it shows also fb. If both fa and fb are equal, then only Rolle's theorem is to be verified. Okay, if all the three conditions are to be satisfied, then we can put f dash c equals to 0, where c represents, where c lies somewhere between a and b, and find the value of c. This c represents the mid value for the given function. Now in the same way we can solve the Lagrange theorem. Statement is almost same. fx is must be a real valued function. Then its first point which need to be satisfied in the given question is same. f of x is a continuous function between closed interval a and b. Then second point, f of x is differentiable at open interval a and b. Third point, f of a is not equals to f of b. Means suppose this is f of a and here it is f of b. It will never be equal. If it is equal, then Rolle's theorem is to be applicable, and if it is not equal, then we can find this with the help of this. If this condition is to be satisfied, then f dash c equals to fb minus fa upon b minus a, and with the help of this equation we can find the value of c, and this c lies between a and b, and this c represents the mid value of the given function. I hope it is clear to all of you. So this is all about the chapter continuity and differentiability. In our next video we are going to solve some basic questions based on these topics. So that's all. Thank you.